Hey guys, so this is Brooklyn again with homework 2 EL6303, and we're going to be doing problem 2. So I'll just put a disclaimer that I am not 100% sure on all the work that is here, but it is what I have come up to with the best of my ability to understand the material. So feel free to comment, explain, or give any feedback that you can. So here we go. So we have a channel, and we're given the probability of x1 equals 0 equals 0.2, and x1 equals 1 equals 0.8 for all of k that is in between 1 and n. And we have the associated probabilities of getting zeros and ones based on what for k plus 1 equaling 1 and 0, and given x of xk is equal to 1 or 0, and the associated probabilities with those. So we're asked to find 4 different probabilities, and so we're going to start with the first one, which is a probability that x2 equals 1. So here we are. I have all these listed, so we don't have to go through them again between paper and paper. So we have x2 equals 1. So we automatically know that k has to equal 1. Okay, so we're finding x2 equals 1. So we take 0.2 from x1 equals 0 and 0.8 from x1 equals 1, because we can have either or, and we can still get 1 or 0 from both of those with the stated probabilities of 0.4, which is here, and 0.7, which is here. So the appropriate math, and we get 0.64. Pretty straightforward. So with B, we have x3 equals 1. So from here we know that k is equal to 2. This is a little bit more difficult because we are only given definite probabilities of x1. So we have to find the associated probabilities of x2. So that is what you see down here. Again, I apologize for the shadow. So we have probability of x2 equaling 0 and x2 equaling 1. So we've already done x2 equals 1 in the previous problem. We got 0.64. We do the same kind of math for x2 equals 0, and we get 0.2 times 0.6 plus 0.8 times 0.3 in order to get 0, because again, we're trying to find x2 equals 0, given that x1 equals 0 and x1 equals 1. We get 0.36. So we have our probabilities of x2. So now we can go back and do probability of x3 equals 1. So we already have all these probabilities listed here. Again, we have x2 now. So we can say that we have the probability that x2 equals 0 and times 0.4 for the probability of where we are given x2 equals 0 and we're trying to find x3 equals 0. So then same goes for when x2 equals 1 and we want x3 equals 1. We have probably 0.7 times 0.64, and we get 0.592. So now we go to C, which is the probability that x1 equals 0, given that x3 equals 1. This, I will admit, was a little bit tricky for me, and I say that I'm not 100% sure, but this is what I think is the answer. So here we are. I always write things out for givens or conditional probabilities. So we have x1 equals 0 and x3, or the intersection with x3 equals 1, over the probability that x3 equals 1. Probability that x3 equals 1 was already found in the previous problem, so we need to find the above the intersection. Now, because of this particular problem and it's x1 equals 0, we can't immediately just use the probabilities that we found in the previous problem for x2, because we are only looking for ones that have x1 equals 0. So that's where we go over here. So we have x2, we're looking for x2 equals 0 with the intersection of x1 equals 0. That's 0.2 times 0.6. And we have x2 equals 1 intersection x1 equals 0. And so we have 0.2 times 0.4, and these are the associated intersections. And so when we do x3 equals 1 and x1 equals 0, we can do 0.12 times 0.4, and we have 0.08 times 0.7, and we got 0.104. So we put these in and we get 0.176. Again, as I disclaim, I'm not completely 100% sure, but this is what I found. With D, we find the limit as n goes to infinity of the probability of x of n equals 0. And again, with this particular problem, I'm also, like C, I am not 100% sure. But based from x1, the probabilities from x1 to x3 for 0 and 1, they seem to be increasing for x but also stalling out, and decreasing for 1 and again stalling out. See, the jump from x1 to x2 is 0.16, whereas the jump from x2 to x3 is only 0.04. So it's clearly stalling as n goes to infinity, and based on the probabilities of achieving 0 given zeros or ones, you have 0.6 and 0.3, and it is in my opinion that they stall out somewhere in between, and that is how I came to the conclusion of 0.45. So again, if you have any questions or comments, or if you disagree with my analysis, then please feel free to comment and let me know. I'd be happy to hear and correct myself if need be. And thank you for watching.